Good morning everyone. Welcome to the Foundations of Engineering 1 class. Today we will cover Chapter 3, Design and Teamwork. Before we go to the Chapter 3, let's look at your lab and homework. So first about your homework, resume. I think most of you did a very good job, and I was a little bit surprised because it's very good actually. But here's a little information that I compared what is the poor resume and what is good resume. The poor resume, as you can see, is harder to read, but good resume is easy to read and well organized with important components. Okay. And try to use concise words, okay, not a long sentence. And please use consistent color. Some students used multiple colors, like 3 or 4 different colors. It's okay through the monitor, but it's not okay when you hand out as a printed versions. Okay, so I would like to recommend you just use a black color only. Okay. And use consistent format, and try to use bold. Here's a little more information here. So when you print out your handout, the resume, you may need to use the Times New Roman character because as for improve readability, Times New Roman is much better than Arial Black. In other words, online submissions, Arial Black is much better to read compared to the Times New Roman character. Okay. About the consistent, concise words, use bullet points. That's very simple and very well highlighted. Okay. Please important information upfront. And I noticed that some of you added your GPA score, which is very good information. Not just qualitative information, but also if you provide quantitative information, the employer will objectively judge your skill and your ability. Okay, that's pretty important. Okay, and try to avoid to use center alignment. Try to use left alignment, because how human beings designed that way. People read from the left to right side. So you should use left alignment, not the center alignment. That's key. Let's criticize this resume example. I just downloaded from the Google. His name is Chris Smith, so I can understand. I can see his home address, contact information, and for a very hierarchical, but it's too little more detailed information there, and there seems like too many bold. That's issues, I think. But there are many good things. It's well organized. As you can see, the education, most important level, up front. And he added his GPA score 3.3 out of 4, which is not bad. And he used the bullet points to highlight what he has, some experiences, additional experiences, and he used only black color only. Consistent format, he used the Times New Roman in this case. Good. So let's look at the Chapter 3 today. Today we are going to learn 3 things. First, know how to design the process. Okay, how we design the product. Okay, I think every one of you knows about Steve Jobs. Okay, how picky is. He is a very well-known person in design area in terms of engineering aspect. Okay, so we will look at his video shortly. And the second one is how to design the experiment. We may need experiment to verify or validate whether your design, your idea is good or bad. Okay, we may need some small experiment. Then how we design the small experiment, that's the question. And the third one, how to design the team. Okay? You may need a team, not just to yourself. Design is a very difficult and very long process. You cannot handle all the process by yourselves. You may need a team, and each team has each person who has a special skill to solve the certain area, certain problems. Okay. Let's look at the video.
Design's a really loaded word. I don't know what it means, and so we don't really talk about design a lot around here. We actually just talk about how things work. Most people think it's how they look, but it's not really how they look, it's how they work.
I think Steve is a design champion by action, not by talking about design. It's that he's a collaborator, that he really understands design, not academically, but as a participant.
Steve not only...
Alright, so what did he mention? Steve Jobs, he said, well, in his mind, design is not just good looking. Design is kind of how it works. Okay. So he focused on functions, okay, functions of each product, not aesthetic, beautiful, some out looking. That's not a big issues in design. Design in engineering aspect, you have to focus on how it works. Okay, so let's think about that concept of design. Okay, let's look at the 5-step process. Design is a very creative process. Okay, here is the definition. Design is not something. Okay, design is a very long process, creative process. We have to define the problems. We have to generate the idea, we have to select the idea, and simulate the idea, and evaluate it. These are 5 steps. I'm not asking you memorize these all steps. It's generic concept, generic process. We can apply this process to every product, okay? But you don't need to memorize each concept, because you're gonna be familiar with this concept. So first step is defining problem needs. What is user's needs? In this step, we may use several different tool or method or skill. For example, voice of customer, focus group interview, naturalistic observation. What is voice of customer? Voice of customer. When I was graduate student, where I had a chance to work with the Hyundai Motors company to design new bus seats. Because the Hyundai Motors did a little survey, and they found that their existing bus it has some issues, such as it's too steep, and discomfort, improper fit, and these accommodation issues. Okay, there was a problem. They defined the problem. They define these problems. That's the one way we can do the survey, and we analyze voice of customer. The other one is focus group interview. Let's think about refrigerator design. Okay, how to design the refrigerator inside. First, we have to define the problem. How to define the problem? Well, we can recruit the housekeepers who frequently use this product in home. Okay, so probably they have more opinions. They know more problems about the current product. So we call it, this is focus group interview. Focus. Okay. So they will tell you number of problems, number of existing problems, number of complaints. This is good steps to understand what is the user's needs. Last one is naturalistic observation, which is very, this is very observation-based concept. We can record a video how user use the product. As you can see the image here, there's a big window here, and there is an observer and a participant. Here the child playing toy, right? So observer, they usually don't intervene. They do not interrupt while the participants are doing their tasks. So in this observation, the key thing is do not intervention. We want to see how a user naturally use their product, and then find out what is the problems or something we didn't notice when we are designing product. We want to find some unexpected situations while they are playing toy, while they are using some iPhones, anything. Okay, so it's user observation survey. Back to the complaints about the users from the user, we can easily convert the complaints to the user's needs. Okay, so for example, the refrigerator is hard to clean up. So what is the user's needs in this case? They want easy to clean refrigerator, bad smell. They always want good smell, large space, and they want easy to arrange fruits and vegetables. Okay, these are user's needs. But think about this way: always use positive words when you change the complaints to the user's needs. And after we define the problems, we may need to generate ideas. But before we generate the idea, it's always a good thing to defining what is the constraint and what is criteria of our product. Okay, so let's look at the bus score. We cannot change the bus score to blue or red or greens. The bus score always yellow because most of people they are thinking, oh, yellow bus is school bus, so we have to be very careful, okay, because many kids are in there. So if we change the color, the yellow bus to the black or green or blue, well, I'm not so sure it's violated the law, but we have to keep this yellow color when we design the bus seat. Okay, that is constraint. So something this is legal issues or ISO standard, we have to satisfy this rule. But the other criteria, we can change this criteria. The criteria is a matter of standard or attribute of design, such as performance, durability issues, accommodation issues. This is our criteria. Okay. So for example, bus seat accommodation, we want to improve the accommodation rate of the bus. Okay, we can change the seats, we can add number of seats more. That's fine. That is criteria. Okay. So we defining the problems or users' needs. Second step is generating idea based on the defined constraint and criteria. Okay. Let's look at the brainstorming and benchmarking. Brainstorming is, use your brain to generate an idea. Okay. In this concept, quantity is important, not quality. We are not talking about quality here. We always talking about quantity. Make a bunch of ideas within a certain amount of time. Okay. So we want to pursue variety of ideas. So not just to work by yourselves. You have a team, okay, 3 or 4 people sit together and generate idea using their brain, okay. And the key thing is don't criticize the other guy's ideas. Always cheer up. Oh, your idea is best. Yours is great. Let's keep your ideas, okay. And then where is quality here? Quantity is quality. Okay. So we can generate, let's say 30 or 40 ideas per person. And if we have 4 persons in one team, then we can make more than 100 ideas. Okay. Among the 100 ideas, we can evaluate. These are the examples of refrigerator ideas. Okay, so we know the customer's needs, what is the goal of this idea, concept of idea. Does this idea can improve the significantly from the existing design? Okay. Another way is benchmarking. Benchmarking is a little bit different compared to the brainstorming. Okay, benchmarking is we want to find the best practices in the real world. So back to the bus seat design, we collect the 12 different shapes of bus seats. As you can see the flag here. Some bus seats from South Korea, some bus seats from Turkey, Japan, Germany, and China. So we want to see various different kind of the bus seats. So we want to find the best one. So here you can see the Eurobus is the current version of bus seat from Hyundai Motors company. And these bus seats are out of boundary. These seats are selected as the best practice, best bus seat in terms of dorsal comfort, support, lumbar support, seat back overall. All those are criteria. Okay, so we can find each criteria what is the best seat throughout the survey or human subject experiment, and then we find the best practice. We can make a strategy to achieve the best level. Okay, selecting ideas. So as I can show you before, when we finish the brainstorming, you may need to evaluate the 100 ideas. As you can see, each idea has some description. What is the concept of this idea? How to achieve the goal? How to solve the problems users needs? These are images. Sometimes hand drawing are easy to deliver the message. We can attach it more than 100 ideas on the wall, and we evaluate using the stickers. Okay, if you are interested in this idea, then you can give some point. So we call it vote. Sometimes we may need some expert. Okay, these people are expert from Samsung Electronics. They are making refrigerator. Okay, so they can judge the new ideas. By the way, this is Korean, but I want to give you some examples. So for example, as you can see, there are many stickers. The number 4th and 6th ideas has more stickers, so we can simply count how many stickers each item has. So we can select the idea, or we can consider the weight. For example, the seat design, one of the criteria of seat design was accommodation issue, but here you can see cost, safe, weight, and wow effect. Wow. We can put the different weights for each criteria. For example, option number 1 is, let's say, idea number 1, idea number 2, idea number 3. They got each score, and we can multiply the weight. The total score, according to the weight, the option 1 is the highest. Okay, so we can use weight issues. Now after the benchmarking, we can find which design shape is much better. The current design is here, and the best practice has more protruded the bolster shape and more flattened the central shape. So we have to change our bus seats catering toward the flattened lumbar center support and protruded lumbar side support. Okay. So after selecting the idea, we can generate the prototype. Okay. These are the example of prototypes. Here you can see some examples. Mobile phone. When we design the mobile phone, you can generate many ideas, and you can make a prototype to evaluate your ideas. Okay, but here they're a little different. This prototype looks very functional and very realistic prototype. How about this one? This one has no function, but the shape-wise, it's very same. It's very similar to the real product. This one is made by paper. It looks like a BlackBerry mobile phone, but it's quite simple to evaluate your idea. It's not necessarily have a very high quality prototype to evaluate your idea. Okay. So here is a little chart. So paper prototype is size-wise is okay, but function and appearance-wise, it's not good. But cost-wise, it's very effective. Visual or working prototype, size, appearance is great. Functional prototype, function-wise is great. A working prototype is very similar to the real prototype. User experience prototype is almost same to the real prototype. Okay. So we can define the type of the prototype depending on their fidelity. Here is the bossy prototype. Can you guess how much price for fabricating this prototype? Bus seats? It's $5,000. Okay, it's very expensive. That means when you making a prototype, before you making the prototype, you have to be very careful to select your idea because it's not cheap. It's very expensive. Okay, once you build the prototype, you cannot go back. Okay, so before we making a prototype, okay, think wisely. Testing. Here you can see the existing bus seat and the new bus seat. Now we have a new bus seat. Let's compare which one is better. But be careful, we are not going to ask which seat is better. It's silly. Okay. We have to design the experiment very carefully to find out the fair evaluation result. Okay. So for example, can you think about that? If the two seats, the height are different, if their heights are different, is it fair evaluation? Probably not. Okay, because seat height can affect to their sitting comfort. If it's too high or too low, it can affect to the sitting comfort. So before we compare the two seats, we have to control the seat height for two seats. Okay, that is control variable. Okay, whereas independent variable. Independent variable is here we want to compare shape. Okay, shape is independent variable. What is dependent variable? Let's say comfort or accommodations, convenience. Those are all measures. Those are dependent variables. So we prepared 12 different bus seats. They have different shapes. Shape is the independent variables here. And how about their cushionness? Their cushionness is a little bit different. Okay, that's independent variable. But we control the seat height. That's for sure. Dependent variable is criteria. Usability, biomechanics, or emotional aspect. What is the measures? So for example, in usability wise, we can evaluate overall comfort, controllability, easy to combine, adjustability. That's a criteria. Okay? So we can build this kind of fancy questionnaire. So for example, you can see headrest or dorsal support each component, or we can ask some certain task. What is the measure? Height, breadth, shape. This is our criteria, dependent variable. So these are independent variable and these are dependent variable. These are 7.3 equal to scale. So whether the headrest while you are sitting, the height is comfort, then you will give 7 points. If it is not comfort, then give 1 point. Okay. So control variable, as I mentioned, then we have to control the experiment very carefully to avoid any other confounding effect to the experiment. For example, we can control the room temperature. Sometimes room temperature can significantly affect to the participants' feeling thermal comfort. Okay, so we fix the room control, we fix the temperature of the room every single time, and we control the seat height and the distance between the seat. We control the as 850 millimeters. Another way in our textbook says a period analysis for how to design the experiment. Okay, P stands for the parameters of interest. The E stands for establish the range of parameters. These are the method. Okay, period method, which is good. I think it's easy to remember how to design the experiment. But you have to think about this. Don't forget, your time and budget are limited. Okay, when we are doing some experiment in engineering side, you always think about the money, okay, and time. So try to design your experiment optimally to get the result, very robust result. Okay. The design process, as I mentioned in the beginning, you cannot do yours by yourselves. Okay, you may need a team. But I would like to recommend you, when you design the team, try to recruit multidisciplinary people. Okay. So we have mechanical, electrical, and mechanical engineering technology. Try to recruit different people. Okay? And there should be a leader and follower. Leader has a big picture, vision, and how to know some sense of how to share the workload. Okay. These are the team when I designed the bus seats. These are the sponsor, Hyundai Motors company, and the postdoc when where I graduated. My former advisor, Dr. Hee-Chan Yu, he was a principal investigator of this research. I was a project leader, and Dr. Hwang Park, Peter Choi, Hyeon Lee, they did different job. For example, Dr. Park, she did a voice of customer survey, and Peter Choi did a human subject experiment, and Hyeon Lee, she did 3D design modeling. Okay, so as you can see, each team member has different role. And Hanel Interior, they build the prototype. Okay. Project planning and management. Let's design the timeline. For example, you have 1 year to design the bus seats. What is your task? What you need to finish to design the new bus seats? What is the supplies? Okay, how much money you need? Alright, if you have 1 year, let's start the meeting at 2012 May. And we development experimental protocol and did a customer survey and designed the new bus seat based on the benchmarking result. And we can develop the prototype with outsourcing and testing. Fine. It's a 1 year process, very long. So design process, it takes a very long time. So think about the team. You always pursue the dynamics. You have to well communicate with your team member, trust them, respect them, and the team has a little more flexibility. Okay, Design it's a little tough, but it's a long process. But you will find that when you see the achievement, it's very delightful. Okay, have fun. We learned 3 things. First, we learned the design process, the 5-step process. The second, we know how to design the experiment. What is independent variable, dependent variable, and what is control variable. Okay. And how to design the team. Thank you for watching this short video. See you next time.